The last transformation that we want to discuss is the shear or the skewing transformation. Now the shear operation we are familiar in the strength of material. Suppose we have given here one solid block and it is rest on a fixed surface and the bottom surface is a rigid surface. So no displacement is allowed at the bottom surface. If we apply the force parallel to the top plane, in that case the given figure ABCD will get distorted. So we have ABCD. We will visualize in the front view. After we apply the force, we will get a deformed shape here. A will not change the position, even the D will not change the position. Position of B will change to B prime. Here A and A prime is one and same, D and D prime is one and same. Position of C will change to C prime. So if I overlap both the figure, then you get the idea about the shear. Point A and point A prime are one and same. B will displace the position along the x direction will become B prime. C will displace along the x direction will become C prime. Position of D will not change, it will be same as equal to D prime. So the transformation that slants the shape of an object is called as shear transformation. Hence the shearing transformation distorts the shape of the object. There are two types of shear transformation we can carry out. One is a X shear and second is a Y shear. Along the X shear, you have to apply the force. Then whatever the figure we yield as A prime, B prime, C prime, D prime, that will be called as X shear. Similarly, if we apply the force along the Y direction, it will result in the Y shear. So two transformation we'll study this time. One is a X shear transformation and second is a Y shear transformation. So first we develop here the X shear matrix. So in the case of X shear, the coordinate of Y will not change. So this one is a figure before we apply the shear. After we apply the shear, the position of A will not change, position of D will not change. So A and A prime are overlap. Similarly, D and D prime will overlap. The B will shift to B prime. When B will shift to B prime, the Y coordinate will not change, but X coordinate will change. And C will shift to C prime. Again for C, when shift to C prime, the Y coordinate will not change. So Y prime will remain same as equal to Y. So Y coordinate will not change. So we have Y prime will be same as equal to Y. But the coordinate X will change. In that case, we have X prime is equal to X. Plus we have shearing factor along x direction multiplied by the distance y. So we have new coordinate is p prime is given as p multiplied by the shearing transformation matrix as shx. So we have p prime is same as equal to x prime, y prime is given as p, which is x, y. We want to write down x prime is equal to x. So x is multiplied by 1 plus y multiplied by shx. shx, that is the shearing factor along the x direction. Whereas y prime is only y. So x multiplied by 0 and y is multiplied by 1. So this one is a shearing matrix along the x direction. Using this, we can calculate the transform point A prime, B prime, C prime. Suppose the given figure ABCD is not at origin. In that case, all the 4 points will change their position. So let's say initially we have coordinate of A is equal to 1, 1, 2, 3, 4, 5. Coordinate of B is 5. Then coordinate of C is 5, 1, 2, 3, 4. 5, 4. Coordinate of D is 1, 4. In this case, suppose we are using the shearing along the x direction is equal to 1.5. So we have to calculate the value of x prime is equal to x plus shx, that is 1.5 multiplied by y. And the y prime will not change, will be same as equal to y. So if we say the original coordinate of point A is 1, 1, it will be transformed to A prime. using x plus 1.5y. X prime is x plus 1.5y. We have x is equal to 1 plus we have 1.5 times y, which is 1, and y value will remain same. Y value is same as equal to 1. So in this case we will get a prime as 1.5 plus 1 is 2.5 comma 1. So this point A will shift to the new point. It will be 2, this will be 3, so this is 2.5, so it will take the position of A prime. Similarly, we can calculate the position of B. Right now the original coordinate of point B is 5 comma 1, 5 comma 1. So we'll get a B prime is equal to x prime is equal to x plus 1.5y. We have x is equal to 5 plus 1.5 multiplied by 1 comma y prime will not change, that equal to 1. So you will get a B prime is equal to 1.5 plus 5 is 6.5 comma 1. So we have 5, 6, 7. So somewhere we have 6.5. So this point represent here the new position of B after transformation is equal to B prime. Similarly, the position of C will also change. Originally we have C is equal to 5 comma 4. So we have 5 comma 4. In this case we have C prime will be equal to x, which is 5 plus 1.5 multiplied by 4, and the y coordinate will be same as equal to 4. 1.5 into 4 is 6, 6 plus 5 is 11. So we have C prime will be 11 comma 4. We have 7, then we have 8, 9, 10, 11. So 11 comma 4. So here we get the position of C prime, and we have D, which is a coordinate of 1 comma 4, 1 comma 4. So D prime will be equal to x plus 1.5, that is 1 plus 1.5 times y. Y is equal to 4. Then y coordinate will be same as equal to 4. So we get D prime. 1.5 into 4 is 6, 6 plus 1 is 7, and y coordinate is remains same as equal to 4. So we have 7 and 4. 7 and 4 is somewhere here. So this one is the new position equal to D prime. So originally we have a rectangle A, B, C, D. After we perform the x sharing with a factor equal to 1.5, you will get A prime, B prime, C prime, D prime with the coordinate as shown here. So whenever we do the sharing along the x direction, the figure gets sheared along the x direction. But in the process, the figure is also get shifted along the x direction. But if we have the points on the x-axis, in that case, when you perform the x sharing, these points which are on the x-axis do not get shifted if the points is on the x-axis. We have two figures given here. Here AD is lying on the x-axis, and in the second case AB is not lying on the x-axis but away from the x-axis. So whenever we are performing the sharing along the x direction, the figure gets sheared along the x direction. That is true. In both cases it will get sheared along the x direction, but in the process it also gets shifted along the x direction. That is in the second case, when the point A and B not on the lying on the x-axis. The extent of the shift is proportional to the distance of the point from the x-axis, but your point A and D on the x-axis, then after sharing their position will not change. The sharing matrix is given as 1, 0, SHX A. Sometimes SHX is represented by A, and sharing along the y direction is represented by B. So we have discussed here the sharing along the x direction. In the case of y shear, which preserves the x coordinate, means the x coordinate will not change. But there is a change in the y coordinate which causes the horizontal lines to transform into the lines which slopes up or down as shown in this figure. So we have originally ABCD is a rectangle, and after we perform the y sharing, the position of A and A prime will remain same. The point B and B prime will remain same. Position of C will change to C prime, and the position of D will change to D prime. So this one is called as y sharing. In this case, the x coordinate remains same. So we have x prime will be same as equal to x, and we have to calculate the y prime. Y prime will be equal to y plus we have sharing factor along the y direction multiplied by x. So we have p prime is equal to p multiplied by the sharing matrix along the y direction. We have p prime is same as equal to x prime, y prime, p is equal to x, y. Now x prime will remain same as equal to x. So x multiplied by 1 will be x, y contribution is 0. So we have x prime is equal to same as x. Secondly, we have y prime is equal to y plus shy into x. So this term must be sharing along the y direction, and this term must be equal to 1. So x multiplied by shy plus y. So this one represents the sharing matrix along the y direction. And if we do the sharing along the x direction, y coordinate will not change. X coordinate will become x plus shx multiplied by y. And in this case, we have sharing matrix is 1 shx 0 1. And in the case of sharing along the y direction, we have 1 0 shy 1. So this is the idea about the y shear. A rectangle with vertices P 0 0, Q 4 0, R 4 5 and S 0 5. The following transformation are performed. In the first case, x sharing with A equal to 2, followed by y sharing with B is equal to 3. We have to perform two operations. First is x sharing with a factor equal to 2 and y sharing with a factor equal to 3. And in second case, you have to do both x and y sharing with a factor equal to 2 and factor equal to 3 respectively along the x and y axis, and you have to find out the final coordinates. So when we perform the x shear, y coordinate will not change, x coordinate will change, and the x coordinate is given as x plus shx into y. So final point we can calculate as p prime is equal to p into shx. This value of shx you have to use equal to a is equal to 2, and we can write the matrix as x prime y prime is equal to xy 1 shx 0 1. This time we have given the 4 coordinates, so you have to calculate x prime of p, y prime of p. Similarly, you have to calculate x prime of q, y prime of q, x prime of r, y prime of r, and x prime of s, y prime of s. The x coordinate of point P is 0 0. Q coordinate is 4 0 4 0. R coordinate is 4 5 4 5, and S coordinate is 0 5 0 5. We have to use the value of shx equal to a is equal to 2. So hsx is replaced by 2. And now you have to solve the matrix. So we have 0 into 1 is 0 plus 0 into 2 is equal to 0. Then we have 0 into 0 is 0 plus 0 into 1 is equal to 0. Now point P is in origin, so that will not change. Then we have 4 into 1 is 4 plus 0 into 2 is equal to 0, that is we have 4 left. Then we have 4 into 0 plus 0 into 1 is 0. This point is also on the x-axis, so x coordinate will not change because it is lying on the origin. Then we have 4 multiplied by 1, that equal to 4, plus 10, that is equal to 14. 4 into 1 is 4, plus 10, that equal to 14. 4 into 0 is 0. 5 into 1 is 5. So we'll check here, y coordinate is not changing. Then we have 0 into 1 is 0, plus 5 into 2 is equal to 10. And then finally we have 0 into 0 is 0 and 5 into 1 is 5. So as defined here, the y coordinate is not changed, 0 0 5 5 0 0 5 5. Since here p and q, they are on the x-axis, their x coordinate will not change, but the coordinate of r and s will change. So this one is our x sharing. In the case of y shear, x coordinate will not change. So x prime will be same as equal to x, y prime is equal to y plus shyx. In that case, we can calculate p prime is equal to p into shy. P prime is same as x prime y prime. P is xy and shy value you have to select is equal to b. So we have shy is equal to b, and this time we have given the value of b is equal to 3. So after this step we are performing the y shear, so we can get the final point as xp prime yp prime. Likewise we'll get qrs. The final matrix is available with us is 0 4 0 14 5 10 5, and the sharing matrix is 1 0. This time we have to use the value of shy is equal to 3, and then we have 1. So again multiply and find out the final coordinate after x shear and y shear. What is the coordinates of p q r s? So we have 0 into 1 is 0, 0 into 0 is 0. Then we have 0 into 3 and 0 into 1 again equal to 0. 4 into 1 is 4, 0 into 0, so we have get 4 answer. 4 into 3 is 12, plus we have 0, so we have 4 12. 14 into 1 plus 5 into 0 is same as 14. 14 into 3 is 42 plus 5, that equal to 47. 10 into 1 is 10 plus 5 into 0, that equal to 10. So x coordinate will remain same, that is not changed. Actually we don't need any calculation if you know the basic procedure. And finally we have 10 into 3 is 30 plus 5, that is equal to 35. So these are the coordinates of p 0 0 4 12 q coordinate. Coordinate of r is 14 47 and coordinate of s is 10 35. After we perform the x shear with a factor equal to 2 and y shear with a factor equal to 3. In the second part we have simultaneous x and y shear with a factor equal to 2 and factor equal to 3. So this time x and y shear is a simultaneous. Hence we have y prime is given as y plus shyx, which is same as equal to factor b. We have x prime is given as x plus shx into y, where shx you have to use equal to 2. So we have p prime is equal to p into the combined sharing along the x and y direction. P prime is same as x prime y prime. P is equal to xy. So we desire here x prime is equal to x. So we have to write here this value is equal to 1, and y is multiplied by shx, and shx is equal to 2. Then we have y prime is equal to y, and x is multiplied by shy, whose value is equal to 3. So this value is same as equal to 3, and y value is equal to as it is, so this must be equal to 1. So this one is a combined sharing. So the combined sharing is same as 1. Then we have shx, then we have shy and 1. Using this we can calculate the final point p prime q prime r prime s prime. You have to just do the multiplication with sh. So here we write x prime y prime of point P, Q, R and S. The coordinate of P is 0, 0, coordinate of Q is 4, 0, coordinate of R is 4, 5 and coordinate of S is 0, 5. And we have sharing matrix is 1, 3, 2, 1. So we have 0 into 1 is 0 plus 0 into 2 is 0. 0 into 3 is 0, 0 into 1 is 0. Since the point P is lying in the origin, there is no change in the coordinate due to both x and y shear. Then we have 4 into 1 is 4 plus 0, that is 4. Then we have 4 into 3 is 12 plus 0, so we have 12. 4 into 1 is 4 plus 5 into 2 is 10, 10 plus 4 is equal to 14. Then we have 4 into 3 is 12 plus 5 into 1. So we have 12 plus 5 is equal to 17. We have 0 into 1, 0 plus 5 into 2 is 10. We have 0 into 3 is 0 plus 5. So the final coordinate of P is 0, 0, Q is 4, 12, R is 14, 17 and S is 10, 5. The video you are watching is from the app, which is the Mohod class app available on Google Store. And in this app, we'll cover all subjects involved in mechanical engineering for GATE. Join the course directly from your mobile. The link is given here.